This video will briefly introduce a wideband millimeter wave multi-beam array using noncoplanar substrate integrated coaxial line Butler matrix. The relevant work can be found in IEEE transactions on antennas and propagation. My talk is divided to 4 parts. It's known that millimeter wave multi-beam antennas enable producing multiple directive beams at the same time, which can serve multiple users at different angular positions simultaneously. Butler matrix is promising choice for millimeter wave multi-beam design, due to its many advantages. Thus it is highly desirable to design wideband, compact multi-beam antenna at millimeter wave frequencies. However, the drawback for the existing millimeter wave Butler matrix arrays is limited operating bandwidth and relatively large matrix size. The narrow bandwidth of Butler matrix can be attributed to the band-limited coupler and corresponding passive circuits. While the existing millimeter wave substrate integrated couplers usually suffer from limited bandwidth and large coupler size. In order to extend the operating bandwidth while keeping a compact matrix size, offset-coupled substrate integrated coaxial lines distributed in different circuit layers are introduced here to realize wideband noncoplanar coupler and Butler matrix. The presented millimeter wave noncoplanar Butler matrix owns a much wider bandwidth while keeping a smaller matrix size. The configuration of the presented noncoplanar SICL coupler is displayed in the figure. Offset-coupled SICL distributed on different circuit layers are utilized to expand the operating bandwidth of the presented tandem-type stub-loaded SICL noncoplanar coupler. Compared with the traditional SICL branch-line coplanar coupler, the proposed SICL noncoplanar coupler realizes a much wider bandwidth while keeping a much more compact size. Considering the -90 degrees phase difference obtained by the presented SICL noncoplanar coupler, modifications on the Butler matrix topology are required. It can be found that the value of phase shifter is chosen as -135 degrees to realize Butler matrix for -90 degrees couplers. Wideband crossover can be realized by cascading 2 noncoplanar SICL couplers. Also, wideband phase shifter can be designed. Compared with the coplanar SICL Butler matrix, the proposed noncoplanar SICL Butler matrix achieves a much wider bandwidth, while keeping a compact matrix size. Here, 2 types of wideband, compact SICL-fed metallic tapered slot antennas with opposite via orientations are introduced to connect the demonstrated noncoplanar Butler matrix. The measured S parameters of the presented multi-beam array is displayed in this figure, showing a wideband impedance bandwidth of 64.7% ranging from 23.5 to 46 GHz. The mutual coupling levels are lower than -15 dB at most frequencies within 25 to 45 GHz. Desirable multi-beam performance over a large bandwidth can be realized by the presented multi-beam array, with its beam coverage ranging from plus or minus 82 degrees to plus or minus 43 degrees. Finally, a conclusion is given. Considering the advantages of wideband, compact size, ease of integration, the presented multi-beam array represents a promising candidate for millimeter wave wireless applications.